I am Mohamed Ashiq PM, head of the PG Department of Economics, Safa College. Here we discuss the new topic multicollinearity. It is a topic from basic econometrics, and in this session we discuss only meaning and nature of multicollinearity and reason or sources and consequences of multicollinearity. First one, the nature of multicollinearity. We know in econometrics, major three econometric problems are there. First one, heteroscedasticity and autocorrelation and multicollinearity. In this session, we discuss about only multicollinearity. Okay, and the term multicollinearity is due to Ragnar-Frisch. And the concept is what? It is originally mean that the relationship or exact or perfect relationship between explanatory or independent variables, explanatory or independent variables in the regression model. That means that in a regression model, there are so many explanatory or independent variables. If there are any relationship between these two or three or more variables, explanatory variables, then we can say there have multicollinearity in this regression model. Okay, here the one example, 3 variable regression model example, yi is equal to beta cap 2 x2i plus beta cap 3 x3i plus u cap I. Here x2i and x3i are the two explanatory variables and yi is the dependent variable. Okay, here x2i and x3i are explanatory variables or independent variables. If there any relation between these two variables x2i and x3i, linear relation between these two variables, then we can say there is a multicollinearity happen. Okay, then next slide we discuss the picture view or the Balian view of multicollinearity. It's the simplest way for identifying the multicollinearity or understanding the multicollinearity. The first diagram A or picture A, see that no collinearity or no multicollinearity. It is because of here the rounds are y round and x2 and x3 and these 3 rounds, and x2 and x3 are no overlapping in first picture. So there is no multicollinearity or collinearity. In second picture or picture B, there is low multicollinearity. That means here x2 and x3 are little overlapped. The shaded portion is seen that. Okay, then we can say there is a little or low collinearity is there. In the next slide, we see that the picture C. Okay, there is a moderate collinearity. Moderate collinearity means there is a moderate level of overlapping between x1, x2 and x3. And the next picture, picture D, is a high collinearity. That is overlapping is highly. Then there we can see the shader portion is high. Okay, then the very high, the last picture is E, very high collinearity. The majority of portion is shaded or overlapped between x2 and x3. Then we can say there is a very high collinearity. Then if the multicollinearity is perfect, is very perfect in our model, in the regression model, then the standard error is infinite. In other case, if multicollinearity is less than perfect, then the standard error is large. These two cases is a problem, okay, which means that the coefficient cannot be estimated with great accuracy. That means we can't get a accurate level of parameter or parameter estimation, okay. It is because of multicollinearity. Then we can say in multicollinearity, the linear relationship only we consider, okay. We do not consider the non-linear relationship between the explanatory variables. So here in multicollinearity we consider only linear relationship between explanatory variables, okay. Then we can study about the reasons or sources of multicollinearity. That is, why multicollinearity included in the regression model, okay. What is the reasons or sources for multicollinearity? Sources of multicollinearity, okay. First one is that tendency of economic variables to move together over time. Tendency of economic variables to move together over time. That means, in example, in the case of income and wealth, in 90% of our examples, when income increases, wealth also increases. So, a tendency of economic variable to move together over time. That means, if income increases, wealth also increases, or income decreases, wealth also decreases, wealth level also decreases. So, it is a common trend or tendency. It may occur, it may create multicollinearity. And the second one is use of lagged values. Use of lagged values means that when we use previous year variables for our regression model, then we can see the problem of multicollinearity sometimes, okay. Then the next one is that the data collection method employed. That means we use more methods for data collection. On that time, some errors are occur. On that reasons, multicollinearity may be occur, okay. Then the fourth one is that the constraint on the model or in the population being sampled. In majority of our studies, we are using samples instead of population. So, when we taking samples from population, it may occur some multicollinearity problems, okay. The next one is model specification. Some regression models specification errors may occur multicollinearity, okay. The next one, an overdetermined model. Overdetermined model means that if some researcher or economist use very less important or unwanted variables in the regression model, then it may create multicollinearity. Then the next one is that common trend. That means in the majority in the case of time series data analysis, we can see the common trend problem. That means if a depression period or recession period, we can see the variables are negatively happen, okay. So, the almost all variables are decreased, or income level or GDP, something like all variables are decreased. It's a common trend, okay. So, the multicollinearity may create there. Then the next one is that we can study about the consequences of multicollinearity. What are the consequences of multicollinearity? In the theoretical consequences are not there. Theoretical consequences, OLS estimators are blue despite multicollinearity. That means that in the presence of multicollinearity, there is also, we can see the blue estimator. Blue means best linear unbiased estimator. The theoretical consequence means that theoretically there is no problem in the OLS estimator, but in practical sense there is so many problems. In the practical consequences are there. Although blue, the Euler's estimators have large variance and covariance, making accurate estimation difficult. That means that although in there is blue, but the variance is very large and covariance is also very large. There is a big problem, okay, in regression model analysis. Then it is because of this problem, large variance, the confidence interval will be wider. Confidence interval will be wider. It make a null hypothesis acceptance level is very high. It make a problem. Okay, and the next one is that the consequence also create statistically insignificant problem. Statistically insignificant problem. Then the goodness of it and R square is very high in this situation, and the Euler's estimators and standard errors can be sensitive to small changes in the data. In the presence of multicollinearity, the estimator, Euler's estimator and standard error are very sensitive. That means when change any data, little change in any data, it will create a very big change in the Euler's estimator and standard errors. Okay, these are the main consequences of multicollinearity. I hope you understand this session. I conclude my session. Thank you. Thank you so much.